This is a Java demo for priority queue. So we know that a queue follows the first in, first out algorithms, but sometimes the elements of the queue are needed to be processed according to their priority. That's when priority queue comes into play, right? So the priority queue is based on priority heap, but without getting into too much details there. What you see here on the right side is the Java architecture, illustrating how interfaces and class priority queue, in this case, how they are organized. On the very, very top, you have iterable, right? This interface allows you to provides the functionality for you to iterate through a collection. This is the reason why collection interface extends iterable interface. So collection interface is also a parent to queue interface. So we went through pretty much all of the above. Priority queue is a class that implements queue, right? So this priority queue basically has everything from functionality standpoint, what a queue has, what a collection has, and also the iterable class, iterable interface has. So priority queue has all of that. Let's look at what's on the left side. So this is our priority queue examples here that I am trying to illustrate. So if you don't do anything, priority queue, let's just say if you start up with an empty priority queue. Let's say if you wanted to order your elements by their natural order, right? So the natural order for, let's just assume that A, Z, B, right, so on and so forth. These are strings, right? So natural order for string is A, right, is less than B, dot, 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 which is, less than Z, right? So if your priority queue has the sense of ordering, right, in this case, it does. What happens is that when you insert something into a priority queue, by the way, this insert is called add, right, in priority queue. So we're just using this to illustrate the concepts here. You have A, if you do Z and then insert B, eventually you're gonna have A, Z, B, right? So in that order. So remember, priority queue is just like queue, right? It's first in, first out. But even though the content looks like this, when you start to remove, let's just assume that there is a remove function, right? Trying to remove the max elements out of this one. And since the max elements, in the natural order is Z, strings representation Z. Z has the max order here. Z is removed, so you ended up with A and B. If you do X and C and so on and so forth, you remove max, and now max is X, right? So this is a quick illustration here. So in Java, all of your algorithms, interfaces, and classes are in Java util start. So let me just do some illustrations here. I'll give two examples. First, I'm going to create an instance of a priority queue. So note that a priority queue has a couple of important basic operations. One of them is called add. So add takes the elements, right? This method inserts these specified elements into the priority queue. So the very first one, let me just create an instance here. So the instance, let's just say priority queue, and this one uses a generic string. So the elements that we are pumping into it is going to be basically a string element. So I want to use the example that we see here, right? A, Z, B, X, C, and so on and so forth. So let me just create an instance of it. Priority queue. And this one is a string, right? Okay, so this gives us an instance of it. And note that, in a constructor, I didn't pass anything in. So by default, if you do just use a custom constructor, the default constructors, the ordering of the elements that you insert in there is by the natural order. For example, if this is not a string but an integer, then the natural order for integer is 1 is less than 2, less than 3, and so on and so forth. And a negative number is less than 0, right? That's the natural order for integer, and natural order for string is as illustrated earlier. So the first thing I want to do is I want to do a queue add, right? Let's just say I'm going to do A and then PQ add. I want to do Z. So this is following the examples that we have above, right? and then PQ, add, and B, right? Okay, cool. The very next illustration is I'm going to use a basic operation. So the other basic application is called peek, right? So this method retrieves the elements that was inserted first. It's basically a top of the queue, right? So what is the top of the queue or the first of the queue? It's going to be A. So if I do PQ and just do a peek, this one is going to peek into that element on top, right? Basically the head of this queue, returning null if the queue is empty. So at this point, if I do a peek and try to run it, I should be getting an A. So the order for this one currently is at A, right? And then you have Z, right? And then you have B, right? Now notice the underlying buffer inside this queue is basically an array. As a matter of fact, no, it's a collection because we're using a collection. But this could also be a linked list, right? It doesn't really matter. So when you do a peek, the very first one is going to be A. So let me just go back to my code and let me just illustrate another method. So this other method that I want to illustrate is called poll, P-O-L-L. This method retrieves and removes the head of the queue or returns null if the queue is empty. So it's very similar to peek, but in addition to peeking into it, it also removes the element on top, right? So if we do this, you poll, we should basically be removing the element A from it. So if we do a run, you will see 8. Actually, no, this one is POLL. Let's rerun this. You'll see removed. So A is going to be removed. What you're left with is going to be Z and B at that point. Okay, so this one is a pretty, a straightforward use of priority queue. There's nothing different about this being a priority queue, right? This is just like a regular queue, so we know that. So that's one example. Why don't we change this to making sure that this time, we can instantiate a new queue with some sort of comparison involved. So comparison is part of the comparable. Let me just remove this entire drawing all at once here. But this one does not have it. So we're going to have to, what we do is we can write another class. So this class would be the comparator instance. The comparator's instance, as I went through this in earlier lectures, comparator is a interface, right, in Java. So you have to override its compare method. So what we can do is we can kind of jerry-rig this priority queue here by making sure that we can also pass in the comparators in there or instance of it to allow for the ordering of these things in a let's say a descending order. So instead of having A, Z, B in the first in, first out, when you insert elements into it, it automatically goes into the ordering mechanism depending on how your comparator is constructed. So to get this to work, let's just create a nested static class right inside this. You can do that in Java. Let's just call this a queue comparator. This is our custom class that implements what we had before, comparator, right? So this is the Java comparator as part of your Java util. So in this class, because we are implementing comparator and the abstract class that we have there needs to be overridden. So this is the override, right? And this one is the public integer, right? Compare. So remember, a compare in a comparator or a compare to in a comparable produces an integer return. Is either negative, 0, or positive, right? Depends on the order that you want to compare with. So the stuff that we're trying to compare is S1 and string S2. So what we want to do is basically make use of the string instance itself. It's already a comparable type. We can use S2 compare. This one is actually compared to because string implements comparable, right? So you can use compare to S2. So if we return this, what's going to happen is this is going to follow the natural order, right? If S is greater than S1 is greater than S2 is going to be a positive 1. S1 less than S2, in this case 8, right? Comparing to B, for example, is going to be negative 1, so on and so forth. So if S1 is the same as S2, it'll return 0. But we don't want that. We want this to be in a descending order, actually. In this case, we want to return S1, S2, so on and so forth in descending order, okay? So in this case, we will multiply this by negative 1, okay? So you can do that, or you can put a parentheses next to it. It doesn't really matter. So this comparator is something that we want to pass into it. We want to create an instance of it. So one of the constructors, custom constructors you see in PriorityQueue takes a comparator. So this comparator is now an instance inside of PriorityQueue PQ instance that will make use of the comparator when add, right, or find methods is being invoked. So in this case, if this is the same queue, but the only difference is being when we do A, Z, B, we wanted to see, let me just to illustrate this, what the very first one is going to be. The first one should be, excuse me, so it should be Z. Why is that? Well, remember though, when you're inserting A, Z, and B into it, it's also making a comparison. Basically, when the insertion happens, it checks to see what it has and order these things priority. So now, if you were to insert A into it, that would be the very first operations here. And now instead of having 8 and Z, right? Because Z is the second element. The comparator, right? Making use of this comparator is going to automatically reorder this, right? Such that the entire thing will be in a descending order. So instead of having this, what you end up with is Z is now going to be inserted in front of A, right? In front of A. And then when you do B, what's going to happen is, because this is in descending order, now, instead of having this, right, first in, first out, what you end up with is Z, B, A, okay? So that would be the order of this, right, making use of this comparators. So if you like, you can run a couple of tests, right, to see, and you can do a poll, you can do also a remove to check for the order here. So this is an example of a custom priority queue with a descending order comparisons that is built into the instance at construction time.